7.1, we're going to do some Algebra 1 review. So we're going to solve these systems with 3 different methods: by substitution, elimination, and graphing. So 3 different methods. So with substitution, what you want to do is solve for a variable first. So in this case, the easiest variable to solve for would be this y, but it really could be any variable at all. Okay. So if I get y by itself, I'm going to add the x over. So I have x plus 3. Now I'm going to take what I just solved for, and I'm going to substitute that into the other equation. So if this is what y is equal to, I'm going to plug it in right there. So I have 3x plus 2 times the y, and now I'm going to solve that. So distribute it through. So 5x, subtract that over, I get 5, so I get x equals 1. Now, after I get my x equals 1, I have to find the other variable. So I can take it and plug it in right here. My y is going to equal the x, which is 1, plus 3, which is 4. Okay, do another one here. You can solve for any variable. You can take your choose. So you could solve for one of these two, but it's going to leave you with some fractions here. So what I would suggest is solving for one of these two. Let's solve for this x. So if I add the x over this way, I'll have x over here. Subtract the 10 over there. I have 3y minus 10. Now this is my x variable, so I'm going to plug that in for the x there. And distribute and solve. Okay, combining like terms, I have 20y, add the 70 over, be 60, so I get y is equal to 3. Now, after I know the y, I'm going to take that and plug it in here to find the x. So 3 times 3 makes 9, minus 10 would be negative 1. Okay, so that's using substitution. Okay, the next one is by elimination. Okay, by elimination, I want to get either my x's or my y's to eliminate, and it doesn't matter which way you do it. You can choose your way you want to do it. So I'm going to choose x's. So if I multiply by 2 here, okay, all the way through, that makes 6x minus 8y is equal to 2. And I want the x's to eliminate, so I need this to be a negative 6. So when I add those together, I get 6 and negative 6. So if I multiply by negative 3, that gives me negative 6x minus 9y equals negative 36. Now, when I add these together, those eliminate. Elimination. I get negative 17y equals negative 34. Divide gives me y equals 2. To find the other variable, I have to take that and plug it in. So you can take either one. I'll just take the top one. So it'd be 3x minus 4 times 2 is 8 equals 1. Add the 8 over is 9, so I get x equals 3. Okay, with this one here, once again, you can eliminate x's or y's. It doesn't really matter. I'm going to choose y's this time just because I got a plus and a minus. It doesn't really matter though. So I'm going to get those both to be 12. 12 and negative 12. So I multiply this by 4. Multiply this one by 3. Gives me 8x minus 12y is equal to negative 28. 15x plus 12y equals 51. Okay, notice the y's eliminate now. 23x. 23. So x equals 1. Okay, once I know my x, plug it in anywhere up here to find the y. Just use the top one. So now 2 times 1 is 2, minus 3y is equal to negative 7. Subtract the 2 and divide gives you y is 3. Okay, so that is the elimination method. Okay, to solve by graphing, if we do this one by graphing here, what you basically want to do is solve, well, you could just type these into Desmos and get it with the graphing. But if you don't use Desmos, I'll just kind of do it here. You get 2y is equal to negative 3x plus 11, and then divide, get y is equal to negative 3 over 2x plus 5.5. So you'd start at 5.5, go down 3 over 2, you get a graph. Okay, this one here would be y is equal to x plus 3. So you start at 3, go up 1 over 1, you get your graph. Okay, and your solution, if you remember back in Algebra 1, your solutions where they intersect each other. So that point right there is the point 1, 4, which you see we got the point 1, 4 here. Okay, if we do this one by graphing as well, oh, you know what? I just noticed that's an x, yeah, anyway, we're okay. It's in a different order, but that's okay. So this one, if I solve for y, I get y, I'm going to bring the y over here, add to 10, y is equal to 7x plus 10. So that starts at 10 and goes up 7 over 1. This one here, if I solve for y, I get 3y is equal to x plus 10 divided by 3. So 1/3 x plus 10/3. So here and goes up 1 over 3. So it looks like this. So my solutions where they cross, which is the point negative 1, 3. Okay, so the solution is always where they intersect each other. Okay, now there are some special cases as well. If you think about the graphs of things, if you get graphs that are parallel to each other, it means there's no solution. If we get one graph and the other graph is right on top of it, okay, it's the same solution, then there's an infinite number of solutions, and it's anything on this line. At any point on this line would be a solution. So if let's use elimination. Okay, so I'm going to multiply here by 2 to get 6 and negative 6. This would be 6x minus 4y is equal to 8. Negative 6x plus 4y is equal to 7. Okay, now notice that both the x's and the y's cancel, so I have 0 on this side is equal to 15, and 0 does not equal 15. Therefore, there is no solution to this problem. What you would have if you would graph both of these is you would have two parallel lines. Okay, this one here. Okay, so negative 8x plus 2y is equal to 4. Notice those cancel, and those cancel, so you have 0 equals 0. This is where you have one line right over top of each other, so you have an infinite number of solutions. Okay, and those solutions are anything that happened on this line. So if I just solve for y is going to equal 4x plus 2. Okay, so there's anything on this line would be a solution. So one way we could write this solution would be we have a certain x, and the y would equal the 4x plus 2. Okay, so that's how you could write that solution out. In Algebra 2, you then got to nonlinear systems, okay, with x squared and so forth. So we'll solve a couple of these here yet too. Okay, by using substitution, okay, if I solve for x here, I know that x is equal to add the 3y over. Then I can take that, and I can substitute in there for that x. Okay, and you guys have gotten very good at solving quadratics. Okay, so first we're going to have to multiply this together, right? So 3y minus 4 times 3y minus 4, right, is 9y squared plus minus 12y minus 12y be minus 24y plus 16. Okay, multiply this through. 24 times 3. Okay, add these y's together, be negative 74y, bring the 5 over, and I have a quadratic to solve now. I just noticed that this doesn't factor, which means I went back and looked at how I copied this problem down, and I copied it down wrong. So you could solve this. You'd have to use a quadratic formula and then plug it back in. But I'm going to make it so it can be factored. So I'm going to copy the problem down correctly and then work it out that way so it can be factored. Okay, this is supposed to be plus there. Okay, so if I solve for that x, I get negative 3y minus 4. So when I plug it back in there, 3 times negative 3y minus 4 squared minus 2y is equal to 5. Negative 3y minus 4 times negative 3y minus 4 gives you 9y squared plus 24y plus 16. Okay, so now multiply through there. 27y squared plus 72y plus 48 minus 4y. Okay, and then I'm going to add these y's together. When I subtract that 5 over to get it equal to 0. Now it can be factored. 27y times 1y plus 43 and plus 1. Okay, those outside and inside give you the 70. So I get negative 43rd 27ths, and negative 1 is the y's. These are what y equals. And to find the x's, I can plug them in there. When I plug this in, I get y is equal to, x is equal to 7/9. And when I plug the negative 1 in, I get negative 1 for the x. So those would be my two solutions right there. If you look at it graphically, this graph looks like this. Okay, so we have a graph here that looks like this. And we have another graph that comes through like this. And our solution are these 2 points right here. So this point is this point right here. And this point here would be this point right here. Okay? Sorry, wrong graph. The graph would look like this coming through. Anyway, same idea. Those 2 points are those 2 points right there. Okay? Alright, to use elimination, you can also use elimination sometimes. Notice here my y squareds would cancel out if I add these together. So I get 3x squared, y squareds cancel, equal to 12. Divide by 3 on both sides. And I get x is equal to plus or minus 2 when you take the square root. So x is equal to 2 or negative 2. Okay. Then, to find the y variable, I'm going to take it and plug it in here. So if I put the 2 in here, 2 squared is 4. So we have 4 plus y squared is equal to 4. Subtract the 4, and you get 0. Plug negative 2 in here. You get the same thing, you get 4. And once again, square root and so forth, and you get your answer of 0. Okay? So sometimes you could get 4 answers, because this potentially could give you plus or minus answers here, so you'd have 4 answers, 2 with this one and 2 with that one. If you would look at the graph of this is a circle with a radius of 2, something we didn't do this year, and this is an ellipse, okay, and it has, looks like, that graph looks like this. So at 2, 0 and negative 2, 0, those would be the solutions, okay, if you do it graphically. Okay, and the last one there, if we want to solve that one graphically, you can put it into Desmos and get the graph of them. We know this is exponential, so in its exponential growth, okay, so it looks like this. And we know that this one is absolute value. If you think about it, we have, that's our absolute value, right? If I add a y over. So I know that over here at 2 is where it goes like this. Okay, so we actually have 3 different answers here. We got one here, we got one here, we got one over here. So 3 different solutions. And those are the 0.24, for this one right here, negative 2.22 and 0.22 right there, and negative 1.69 and 0.31. Okay, so using Desmos, real nice way of doing it, using Desmos there as well. Okay, a little word problem for us now. Title IX prohibits sex discrimination in sports programs. And in recent years, the national average spent on 2 varsity athletes, one male and one female, was $60.50 for Division 1A schools. However, an average expenditure for a male athlete exceeds those for a female by $3,900. Most of that's because football is a huge major expense. But anyway, determine how much was spent on each. Okay, so first of all, let's identify what X and Y are. So let's say X is the amount spent on males, and Y will be the amount on females. Okay, so first identify that. Now, so the average, so males plus females divided by 2 was $60.50, and it says the male exceeded those for females by $3,900. So I know that the male minus the female would be $3,900. Okay, so here I have my 2 equations to solve, and you can choose substitution, elimination, graphing, whichever method you want to solve it. What I would probably do here is multiply by 2 on both sides. So I'd have x plus y is equal to 12,100. And elimination is pretty nice here, because the y is eliminated already. And I divide, I get 8,000. Okay, so that means that there is $8,000 spent on males, the average male. And if I plug that in and subtract it and add in all that, I get y is 4,100. You can see that a lot less money was spent on females than on males.